Hello, everybody. Today I will speak on the first lecture of signals and systems. Of course, we have a previous lecture that's just an introduction. So today I will speak about first analog versus digital, which is implied from the name that's in analog digital or signal processing. We relies on using elements of the circuits like resistors, capacitors, inductors, transistors, and diodes, which this is the elements that we usually you studied on the electronic one and electronic circuits and whatever. Digital signal processing, in the other side, it's reliable on the adders, multipliers, memory, or storage. So this is a very basic differences between analog digital. However, there is two advantages for the digital approach. The first advantage is the flexibility. We use a hardware that is giving us, if you give it to one operation on this hardware, you expect it to give you outputs that's depending on what is this operation. In analog, the almost all the analog circuits uh, working only on one or two operations, limited number of operations that is capable of doing. In digital, here it is flexible, so it may implement different operation or processes, and just changing on the software like your computer. Do uh, it does millions of operation without changing of the hardware that you use. Repeatability is a second advantage of the digital approach, which is making the digital computers or digital signal processing can work on same operation or multiple operation over and over without having many mistakes, and there is no such changeable or variation in the parameters like in analog systems. So what is the classification of signals that we will work on through this class? There is two type of signals. Here we have the signal that's called continuous time signal. Continuous time signal, that's if in the time t it is continuous variable, so in the time t it continue giving each time, each point at the time it have a value. However, there is another type of signal called discrete time signal. Discrete time signal means that have a discrete time, so it have a discrete value. So at, for example, this is -1, -2, -3, -4, -5. It have only a value at this point of time. At this point, nothing else between. In between, it doesn't have any values. So it have chopping, just like if you have a knife and you chop this signal to only some value. You take some value at a specific point and you leave everything else, you discarded everything else. So this is the main difference between the continuous time signal and the discrete time signal. So continuous time signal, we describe it using the variable t, the independent variable t, and we use this parenthesis. So if x of t, we call it x of t equal, for example, it is well known for us sine signal of 2ft, for example, or 2 by ft, as we will see later. So this is the description or the how we write the continuous time signal. In the discrete time signal, it's using the independent variable n. N is number, it is changeable, 1 2 3 4 5 whatever. So when we use a rectangular bracket, so this is the differences. We use x of n, here we x of t. X of n multiplied by ts. We will see later what it is, but here we see that it is a multiple of values, a value that is repeat itself, or as something that's repeat itself, or at specific points. Okay, now the first subject that we have, we will have some examples on it. It is even and odd signals. Any signal that we have, for example, the continuous time signal, can be said that it is even if the signal, if you remove every t in the signal and put minus t and put in the function of the signal, and at the last you will see that x of minus t equal x of t. So this is the equation, a simple equation. How this is called even signal. So but in the, if we want to make it, it said an odd signal. So if we check, if we want to check if it is an odd signal, so it have to satisfy this condition: x of minus t equal minus x of t. So the minus here appears outside the x of t, outside all of the function inside the x of t. So here, if you put a minus in the x of t, if you remove each t and put minus t, it doesn't have any effect, so the signal is even. However, in the odd signal, if you put minus t, then you will have an effect, a minus outside all the function of x of t. For a discrete time, it is the same. If you have, but here you have n instead of t, x of a minus n equal x of n. Okay, so this is called even, and x of minus n, you will see a minus, just a sign outside x of n. This is called odd signal. Okay, so here we have even like this, which we call it asymmetric around the g of t. So even signal, it is having, if you have a paper and you make this drawing this signal in this side like this, if you chop it to the other side, if you make it half, and you see that all of the points on this side will have a corresponding point on this side, so it is symmetric around the y-axis, the g of t. Okay, g of t, x of t, whatever the function that you have. However, in the odd signal, you will see here that it is not around the signal. Here, this signal doesn't have the same values. It is have a minus. So each point here, for example, this point at minus 2, minus 2, it is 2. It is point at 3, for example, minus 3, it is minus 3. So each point here in this side having the negative value. So this side, it is here. So if you see this tops of this signal g of t, this is here. So this is called odd signal. So if we have the sine of t or the cosine of t, what is the type of this signal, if it is even or odd? Sine of t, if you write sine of minus t, you remove each t and you put t minus t. So sine of minus t, where is the sign? This is the sign. This is the shape of the sign. So it is begin, if you write in your calculator sine 0, it will give you 0. So sine 0, it give you 0. Sine 90, it will give you 1. So if you see here, this is sine wave. Sine wave, it gives you the opposite in the other side, which make the sine signal is odd, odd function. So sine is odd function, so it doesn't eat the sine. Sine doesn't eat the sine. Okay. However, cosine, it's like this. This is the function of cosine signal. Cosine signal, cosine 0 is 1. Cosine 90 is 0. So if you make it in the calculator, you will see this is the function of cosine. The function of cosine is repeatable around, and it is symmetric around the vertical axis. So if you write cosine minus t, cosine minus 90, cosine minus 30, 60, it will have the same value if you write cosine 30, cosine 90, cosine whatever the number that you put here, it is the same if you put a minus or not. So this signal we call it even signal, even function. Okay, so cosine is the sign, cosine is the sign, so it have no effect on the function because it is even signal. Another example from your book, consider this function x of t, it is signed by t over t, where t, the small t, is less than the capital T and higher than or equal to minus t and 0 otherwise. So is this signal even or odd function? Okay, over the time t. Replace, as we know, replace every t that you see, the small t, replace it with minus t. So I will replace this t minus t, and we will see here the 0, the otherwise 0 doesn't have t, so it is same. How I know that this is pi over t, it is just like a number. So sine minus t, my sine, it doesn't eat the sine, so it make it outside like we know before, so the sign is outside. So here this is, I can replace it, this is the same value, so I can replace it by x of t. So I will write here x of t. So x of minus t equal to minus x of t. So this is the condition of odd signal. So this signal we can say that this signal is an odd function. Okay, so almost all the function that we have in reality doesn't corresponding to a basic function. So it just, we can't say that this is function is even or odd directly because it's a complex, or it is a combination of multiple of signals. So some signals have even parts and some signals have odd part, and some signals have even and odd parts, which if you combine all of these parts you will generate your original signal. So we have in our signal we have even part that we want to take it from the signal and know what is this, and odd part, the even part, it is given by this equation. You can take it by this equation, g of t or x of t plus g of minus t, so over 2. But however, the odd part is just the difference is in minus here, this minus g of t minus g of minus t over 2. So g of odd equal to g of t minus g of minus t. So what I should do, I should just, I have already g of t or x of t or whatever the name of the function, I have it. So I will just getting or calculating g of minus t. Then I will just apply these two equation to get the even part and the odd part. And after that I should simplify my equation. For example, if it has a multiple sines and multiple cosines, for example, I would just combine them, summation or subtraction, whatever. So I have a function that is the even part of the function and the odd part of the function. Okay, here he said that it is, if the function have even part is 0, then it will return back to a basic function which is odd, otherwise it is even. The derivative of an even function, if you take the derivative of the even function, it will be odd, and the opposite is okay also. If you take the derivative of the odd function, it will give you even function. The integral, it is the opposite for of the derivative. Okay, so this is easy to know. Now one example, the example here, we have an example about the even and odd signals. He said find the even and odd component of the signal x of t equal e or to the power minus 2t cosine t. So what I should do, first I have x of t, I know from this equation that I have g of t or x of t, and I want to find g of minus t. How to find this one? I replace each t by minus t, that small t that I have, and I leave everything else. So return back. Here I replace each t, a small t, but with minus t for the expression here. So I replace this one with minus t, minus minus t, it is positive t, and I replace this t with minus t. So cosine minus t, it eats the t, so it's cosine t. And I have here e to the power 2 t. Okay, now I have x of t and I have x of minus t. So I will apply this equation. I will sum x of t and x of minus t over 2 and subtracting both of them to get the e odd part. It's easy example. So x of e of t, the even part, it is the x of t and the x of minus t. Here the x of minus t, e to the power 2t cosine t, and x of t, e to the power minus 2t cosine t. I just put both of them and over 2 from outside. So cosine here, if you take cosine and this cosine, you will take as a common, you will leave e to the power 2t plus e to the power e to the power minus 2t plus e to the power 2t over 2. This corresponding to from trigonometry, calculus or trigonometry mathematics, this is equal to, this is reserved image or a reserved function for cosine, for the hyperbolic function cosine. Okay, so you should, I will describe some mathematical trigonometric and mathematical expression in next lecture. So because we usually use this mathematical expression, as I said before, you should, after you get the x of t, you should simplify your function using cosine, cosine-ish, and whatever. So it is yes, in your book, in the last section of your book, in the appendix A1, it have all of these mathematical expression, so you can just review it quickly and you can use it directly. Okay, now for the odd function, you will just have a minus, the same x of t minus x of minus t over 2 from outside. So you will just write it and take cosine t as a common, then you will leave e to the power minus t minus e to the power 2t over 2. So this also an expression for sinish. It just have, you will, this one is the other side, so it is sinish it equal to e to the power 2t minus e to the power minus 2t over 2. So that's why we have a minus from outside. So this is the odd part. So our example here have two parts, even and odd components, which we can get and express using different functions. So this is what we called, I can't say that this function or this signal is odd or even, a pure odd or a pure even function. So it have a simple component that's even and simple component that's odd, and we can get it easily using these two equation. Okay, now as we speak this here, this is a simple equation that doesn't have a complex number, it doesn't have a complex part. Here we have a complex signal. The complex signal is a real signal if its value is a real number. So if it is just have the real part of a signal of a complex number, if you remember what is a complex number is, I think I will cover it today. And a signal x of t here is a complex signal if it is value is a complex number. So if it is a complex number, the same as in calculus, it is a complex signal. So a general complex signal supposed to have both parts. X of t equal a of t plus j a b of t. So j here it is the square root of minus 1, and here a of t and b of t is the real, this is the real part and this is the imaginary part of the signal. From the complex number, reviewing again, the conjugates of the x of t, it is equal x star, we refer it to x star, this is the nomination. X star of t equal a of t minus, so this is the difference between the conjugate and the function itself, minus j b of t. So we just reverse the sign of the imaginary part, and then we have, yes, I think I put something here. This is what I said to you. This is the trigonometry in A1 in the book that you have, Signal System, I think, Hikins. Yes, this book have some, if you remember, this is the right triangle. This is x, y, r. So x over r, it is the cosine. X, y over r, it is the sine. X over y over x, it is the tan of theta. And this is a very simple, I think you all take it before in the algebra, basics algebra or calculus. So you will review this trigonometry because you have to remember it, so you can use it easily in the reduction and the simplification of some equation or some mathematical problems that you have during the class. And this is the other identities of summation or subtraction of two different angles, and this is multiplication of two different angles, sine cosine, sine cosine. So just have a review. Now back to the basic algebra again. The complex number, as I said to you, the complex number, if you have, this is the imaginary axis and this is the real axis, we have a theta here and we have this number. This number have a real part, and j, it is the square root of minus 1. So the real part, it is omega, this one. The real part is the x, and the imaginary part it is y. So here wx plus jy in the number, and we have also a theta and r, this is the polar coordinate. So w equal to r e to the j theta. So r is a magnitude and theta is the phase of w, and you can get it from a1, I think. Yeah, this is a function. This is also included in the basic algebra in the book. You can review it, so you can use it easily in the calculation and in the solution of the problems. Okay, return back. Complex signal is said to be conjugate symmetric. So here we have an odd signal and odd and even signal, but for the complex we call it conjugate symmetric or asymmetric. So why, when we call it a symmetric signal, if you put a minus t in the signal, and if you put a minus t inside the signal, you get the conjugate, then you will say that this signal is conjugate symmetric. So I have, this is our function and this is the conjugate function. If I remove each t from here, each t from this signal, and it will remove to, I will get this one, I will get actually the exactly this one, then I will call it conjugate symmetric. So substituting both of them, x of t and x of minus t here, putting both of them, then I will have this summation. So a of minus t, I remove each t and put minus t here, it's supposed to giving me a of t minus j b of t. So this means that the complex symmetric, when the real part is even, this real part is supposed to be even, and the imaginary part, because it's giving you a minus from outside, so this is the imaginary part, this is here out, from the outside it have a minus, so it changed to be odd signal. So the real part of the signal is even and the imaginary part of the signal is odd, then I will call this signal as conjugate symmetric. So in this example, signals x of 1, x of 2 in this figure continued a real and imaginary part of a complex signal. What is the form of symmetric? So if it is a signal, if this signal is conjugate symmetric or not. Here we will have to see what is this odd or even. So if I see here, if I give it to you as a function, you're supposed to make the mathematical solutions that we have before a very simple solution, just one line or two line. Here you see, if I give it to you as a function like this, it is a graphical or representation of the function here around the symmetrical axis, you will see that is from a point to a point, from 0 to t1 over 2, it have the same amplitude. From the other side, you will see that this is have the same amplitude from 0 to minus t over 1. So this is what we call it a even signal. So this even part, so this is here, he said that the real part is even. Okay, so this is the real part is even. The other one, b, he said that is imaginary part. So the imaginary part, I have from 0 to t over t1 over 2, I have a amplitude of a. So I remove each part and I put minus. Okay, so here at 0 I will have a. So at 0 I supposed to have a minus a. So I already have a minus a. So at t minus t1 over 2, I have a also, so I supposed to have a minus a. And for example, at this point, whatever this point is, I have 0, I supposed to minus 0, so it is 0. So I have in this point I have a, so I have a minus a. Yes, I have a minus a here in the corresponding the same point. Minus t, I have a minus from outside, so it giving me x of 2 minus t, it giving me x of minus x of x2 of t. So yes, it is same here, the minus the amplitude, and this is point, and 0 it is 0. So this signal we call it a odd function, which is corresponding to the imaginary part. Here it's corresponding to the imaginary part of our signal, it is odd, and the real part it is even. So our signal here we call it, because it's a complex signal, we call it conjugate symmetric. Okay, so I think this is the last thing of our presentation today. I will see you next lecture. Thank you for listening.